Okay, so today it's a super exciting day. I'm on my way to go and pick up some parts for our new electrical system in the boat. We have ordered some lithium iron phosphate battery cells, inverters and some other stuff that's just arrived. So that's going to be really exciting to see what we have. I haven't talked that much about what we plan for the electrical system, so I thought I would just go through it quickly. Today we have obviously a 12 volt starter battery for the main engine. We also have a 12 volt battery bank, service battery bank for all the normal consumers that you would expect on a boat, like lights and electronics and fridge and whatever. We have some high power loads as well, which is our electric furling Genoa and hydraulic power pack. The hydraulic power pack is powering our windlass, our Genoa winches and our swing keel. So on a boat this size we kind of maybe expect it to have a 24 volt system. As the boat size increase, also mostly the high power loads increases as well, like it lasts, for example, and around those, if the high power loads at 12 volts, you basically get very high current, and that leads to that you need to dimension cables and so on, whole installation for those currents, and then it kind of it grows too much. You want to switch over to 24 volts. But anyhow, this boat does not have 24 volts for some reason. I don't know why really. So our furling Genoa and the electric hydraulic unit is both on 12 volts as of today. On top of that, we also have quite a lot of 230 volt AC consumers. So we have an electric cooktop, an electric oven, dishwasher and washing machine. So it's basically appliances that you would expect to have at home. Together with that, there's a diesel generator as a power source, and quite small solar panel as well. What's a bit special or interesting is that there is no inverter of the boat as of today. So to run all of those 230 volt appliances, so the cooktop and oven and so on, you need basically either to be on shore power, or you need to run the diesel generator to cook food, which is quite strange and definitely not the way we want it to be. Also on top of this, the batteries that are in the boat today, they are completely dead. They have been standing without charge for more than 10 years, so there's nothing left of them. So what we are going to do is that we're going to install a 48 volt service battery bank based out of these lithium cells that I'm about to go and pick up. It's going to be a 280 amp hour 48 volt system, roughly around 15 kilowatt hours of energy. Then together with that, we're going to have two combined inverters and charger from Victron, two multi-plus, two the 5 kiloamp hour version, which means that we will have and we're going to run them in parallel. So in total, we're going to have a continuous inverter capacity of 10 kilovolt amps, or if you have a purely resistive load, 10 kilowatts, which is quite a lot. And there are some reasons for why we choose to go for that big inverters. We're probably going to go through that a bit later. Yeah, and also together with that, we're probably still going to have a 12 volt system supplying power to all the 12 volt loads on the boat. So in the end, then we will end up in a system where most of the things are running from 12 volts, and then obviously all the 230 volt appliances will run from the 48 volt batteries through the inverters to 230 volts AC. And together with this, we also of course want to add as much solar panels as possible, because our idea is that we want to be able to live out of solar more or less if we have good conditions, and then we'll just have the generator as a backup if we really need it. And in that case, that's also one of the reasons for choosing the big inverters, because they are chosen so that we can really maximize the power outage of the genset, charging the batteries, so we can keep the runtime of the generator as short as possible. Yeah, to charge up. Okay, so here we have the delivery. Two big blue Victron inverter boxes and a lot of battery boxes, also filled with some other stuff. These are the bus bars for the battery cells. some other stuff. And here we have the actual cells. Okay, so this is the last box now. What I'm doing is that I'm just going through all cells, measuring the cell voltage to make sure that they show even results, and then I visually inspect them to make sure that there are no damages on them. So far all cells has been within 3.290 to 3.292 volts. So just 1 to 2 millivolts of difference. So that I would say is really good. This is actually the only damage I found so far. So this is some protective plastic here that's not really bonding the glue here. Okay, so time to pack things up and get going. Okay, so we're all packed and ready to get going for some assembly and top balancing of the battery.
Okay, so here we are again. It's been over a month since we were here last time when we tried lifting the keel.
Yep.
It's been super cold, like below freezing, and a lot of snow. Still some ice left. We're gonna do some measurements for the electrical system with the batteries and the inverters. Decide where we're gonna have them.
And some small other things as well.
Yes.
Just check out so that everything's fine as well.
Yeah. It's quite windy today. Oh, the tarp is really flying. Have to fix that. Winter storms, yeah.
I think you can probably get really windy here as well.
That direction, it's just there's a channel that goes south-ish, and yeah, when the wind comes from there, it's just straight in. The wind probably accelerates a lot in this channel as well. This one has not been broken though.
I didn't expect that one to last very long. Okay, so I'm in the aft compartment between the two cabins, where we have some electrical installation from before. Here we plan to install the new upcoming service battery bank and our inverters and some other electronics as well. So I made actually a template here just to try to fit everything in. This is going to be quite tight. This sheet of plywood has the length of our battery bank, and as you can see, if it's all the way to the end here, it's not that much left over here. We'll see if it will be possible to fit it, but actually the idea first was to build a completely standalone framing for the battery cells, but then it will be this wide, and as it's this tight, I'm actually considering if we're gonna just build it in place here. And then this plywood also has the size down to the line here of our inverters. The idea is to have them something like this. We also need some spacing around them for ventilation, but I doubt we will actually run them that hard. We have two, so either they're going to be side by side like this, or we will mount maybe one over here instead. I think actually that's a better idea. So we have one here, and then we have some space for for some bus bars and other stuff. I was thinking a bit about what these have been used for before, but I guess it's been holding scuba tanks, or it's at least the only thing that I can come up with. But it seems like a bit of a struggle to get diving tanks into here. I guess they're stored good here, at least once they're in here. Okay, so I've taken the supports for the scuba tanks or whatever it was away, and the initial plan was to build a separate battery box that we then put into this compartment, but as I mentioned before, that's gonna be very tight to fit in. So I'm actually thinking about if we're actually gonna try to, instead of building a separate box, trying to integrate it into this structure, so that this will actually be the bottom that it's gonna stand on, and then we will use this wall to compress against, and then on this side we can pick up some small holes for access to the nuts to be able to compress the battery, and then we'll just screw this plate down in and then strap it all in here. So we'll see, that might be our new plan. Okay, so finally got this piece up, and as you can see it's a bit wet on this side. It's quite hard to see, but it's most likely it's wet down here as well. Most likely leaking from somewhere here, but it's very hard to see where.